In section 2.6, we're going to prove angle relationships, similarly to how we proved segment relationships in 2.5. So, when we talk about congruence of angles, it's exactly the same as we've been talking about with segments, except we changed that word segment to angle. So, angle congruence has these same reflexive, symmetric, and transitive properties. So, any angle is congruent to itself. Any two angles, angles A and B, if they're congruent to each other, it doesn't matter which one I write first in the statement. And the transitive property, all right, if A is congruent to B and B is congruent to C, then we can make the leap that A is congruent to C. We're just talking about angles instead of talking about line segments. Same thing. So we're going to use some of these and kind of refresh on what we did in 2.4 and 2.5. So statement 1 is given in my example. And so using our transitive property of congruence, I can make the second statement because both angles 1 and 3 are congruent with angle 2, therefore they are congruent to each other. And remember, this is a POC for congruence. This is a property of congruence, not a property of equality. But from statement 2 to statement 3, we've gone from a congruency statement to an equality statement. We will use our definition of congruency, but instead of congruent segments, this is now congruent angles. Statement 4, that the measure of angle 3 equals 40 degrees, is another given. And so, because we now have the measure of angle 3 in two equality statements, I can set the measure of angle 1 also equal to 40 degrees, and that is because of my transitive property of equality. Our first theorem we're going to talk about with angles is our right angle congruence theorem, which says if two angles both have a measure of 90 degrees, then they are congruent to each other. This may seem like common sense, but unfortunately that's not a reason that we can use in a proof. Okay? So, we are going to prove this theorem, and then we're going to be able to use it to make this logical jump every other time we see this hypothesis. We'll be able to draw this conclusion. Law of detachment, section 2.3, anybody? Alright. So, in our proof of this theorem, our first reason is given, so I'm just going to copy my given statement exactly as it's written. We can use the angle symbol, alright, to substitute for the word angle, and then if it's angles, you put the S. Alright. So where do we get statement 2? Well, if angle 1 is a right angle, then by definition, its measure is 90 degrees. So this comes from the definition, and I will sometimes abbreviate this as DEFN for definition. All right, definition of right angles. Uh-oh, everything else is blank. Well, I know the last statement in my proof should be what I'm going to prove. So this had darn well better be that the measure of angle 1, that angle 1 is congruent to angle 2, which means that their measures are equal. So that must be what comes in the middle, that the measure of angle 1 equals the measure of angle 2, which, going from 2 to 3, I can see that measure of angle 1 equaled 90 degrees, measure of angle 2 equals 90 degrees. So because of the transitive property of equality, I can do that. You might also call this one substitution. Property of equality. Alright, so if it's transitive, you can pretty much always use substitution property of equality instead, as long as it was a transitive property of equality. Congruence, not so much. If it was substitution property of equality, you can't necessarily always go the other direction and always use transitive instead. We'll see some examples of where that's the case, where you could only put in substitution as your reason. All right, and to go from step 3 to step 4, we went from an equality statement to a congruency statement, which means we used our definition of congruent angles. We have now proved our right angle congruence theorem, and we can use it. So what does that look like to use this in a proof? Well, let's look at our given statements for this. Segment AB is perpendicular, all right, is what that means, perpendicular. And we see that that makes a 90-degree angle. So we could say that perpendicular sides create a right angle, or I can say a right angle is formed by two perpendicular sides. But in any case, our reason for statement 1 is that it is given. And then I know, because of my definition of a right angle, that angle B, that's the vertex there, so angle B, all right, the measure of that must equal 90 degrees because of the definition of a right angle. Statement 3 is another one of my givens, and here it says that segment BC is perpendicular to segment DC, also creating another right angle. So I know that the measure of angle C, that vertex, is also 90 degrees, and that's because of the definition. And so because I have now proved my right angle congruence theorem, all right, which said I had to have two angles with their measures equal to 90, and then I could say that they were congruent. So this is my therefore out of that conditional statement. So I can do that, and it's because of the right angle congruence theorem. Again, sometimes I abbreviate theorem as capital T-H-M. Our next theorem that you're allowed to use is the equal supplementary angles theorem. So if I have two angles that are supplementary, and I am told that they equal each other, well, supplementary means that they add to be 180 degrees. So in order for them to be equal, I have to split that in half, so my conclusion is that they both equal 90 degrees. We're not going to go through the rigorous formal proof for this one, because we kind of talked through it. We would just write that out step by step. So we're just going to be able to use that one. What we are going to prove, though, is the congruent supplements theorem and then the congruent complements theorem, which you can imagine is going to look very similar. So if two angles are supplementary to the same third angle, for example, here 1 and 3 are both supplementary to angle 2, common sense tells us that they are going to be congruent to each other. We're going to do our proof here before we move on to use it. But we can also say another way, if 1 and 2 are supplementary and 3 and 4 are supplementary, and angle 1 is congruent to angle 4, then I know, again, a little bit through common sense, but maybe a few more steps, that angle 2 must be congruent to angle 3. We'll prove case 2 for complements instead of supplements. So let's prove case 1. Our first statement in our proof is our givens. Our second statement, if angles 1 and 2 are supplements, then by the definition of supplementary angles, all right, their measures add to be 180 degrees, supplementary angles. Same thing for the measures of angle 2 and the measure of angle 3. Because I now have two things that both equal 180 degrees, this must equal this by our transitive property of equality. So that gives us statement 3. And then I have a measure of angle 2 on both sides, which is not in statement 4, meaning I had to subtract it from both sides, which you'll remember from 2.4 is the subtraction property of equality. And then to go from an equality statement to a congruency statement, that is because I can use my definition of congruent, not segments like in 2.5, but angles. We're now going to use the congruent supplements theorem. It's an if-then statement. We know it is true, we just proved it. So if the hypothesis is true, the law of detachment says that the conclusion is true. So angle A and angle B are supplementary. Angle B and angle C are supplementary. So that is case 1 of the theorem. So we know that our conclusion is that angle A is congruent to angle C. If this was in a proof, and these two were my givens, and this is my next step, okay, whether it's in the middle or the end, all right, the reason would be congruent supplements theorem. In our next example, we are told that angle 1 and angle 2 are supplementary, and angle 3 and 4 are supplementary, and we are told that angle 1 is congruent to angle 3. This is case 2 of our theorem, and so our conclusion in this case is that angles 2 and angle 4 must be congruent. Our congruent complements theorem looks almost identical to our congruent supplements theorem, except everywhere we had supplementary, we're going to put the words complementary. And instead of things adding to be 180 degrees in our proof, things will add to be 90 degrees because that's the definition of complementary angles. So, I'm not going to go over what's written here because it's exactly the same as the supplementary one. We're just going to prove case 2, and then we'll talk through some examples. So in our proof, our first statement is our given. Our second statement is based on the definition of complementary angles. So far we're starting out very similarly. Again, I have two things that both equal 90 degrees, so I know that the left side of both of those equations must equal each other. It's a plus. And that is because of our transitive property of equality. Substitution property of equality also works. Statement 4 is another given. And because I'm working in all of these things that are equal, all right, I'm going to want to change this into the measure of angle 1 equals the measure of angle 3 using my definition of congruent angles. And now that I have this statement of if the measure of angle 1 equals the measure of angle 3, this one I can substitute in and make that the measure of angle 1. So this one, it's not a transitive property of equality. In this case, the only correct answer to our reason is the substitution property of equality, and we substituted into step 3. Again, my last two lines are blank. Oh no. But I know that I want to prove that angle 2 is congruent to angle 4, so that's going to go there. And in order to do that, I have to have said that the measure of angle 2 is equal to the measure of angle 4, which, now that I have the measure of angle 1 in both of these, that's the only thing that's missing in order to get to statement 7. So to get rid of those, I had to subtract from both sides, meaning my reason is the subtraction property of equality. And then to go from 7 to 8, to go from an equality to a congruency statement, means that I used my definition of congruent angles. This means that, again, I can use my congruent complements theorem to draw some conclusions. If angle 1 and angle 2 are complementary, and angle 3 and angle 4 are complementary, and angle 2 is congruent to angle 3, then my congruent complements theorem tells me that angle 1 is congruent to angle 4. Similarly, if angle A and angle B are complementary, and angle B and angle C are complementary, then our congruent complements theorem tells me that angle A is congruent to angle C. Next, I want you to fix one thing here. This is going to be if angle DGC, that is our given angle here, and DGE are complementary, and then we know that these three angles are congruent to each other. We're going to use the diagram to find each measure angle. Now, we don't have to do a proof, all right, but if DGC are 1 in blue and DGE are complementary, we know that 65 plus whatever that is equals 90, all right, because that is the definition of 90 degrees. So the number that goes in there is 25 degrees. So that is this angle. That is DGE, which is congruent with AGB. That's this one over here. So that one is also 25 degrees. And then those two are both congruent with EGF, so this is also 25 degrees. I now have to figure out what this angle is, and it may be a little bit obvious, and this was the theorem that we didn't prove, but if this is 90 degrees, then this must be 90 degrees. And so, again, 90 minus 25, this one is 65 degrees. And then I just have angle AGF, which that plus 25 is 180. So 180 minus 25 equals 155, making this angle 155 degrees. Our last two theorems are the linear pair theorem and the vertical angles theorem. Well, last two for this section anyway. The linear pair theorem says if two angles form a linear pair, then they are supplementary, which means that their measures add to be 180 degrees. The vertical angles theorem says that all vertical angles are congruent. So in this diagram, angles 1 and angle 3, and angle 2, and angle 4. So, let's look at our proof. We are given that 1 and 2 form a linear pair. So this is that there. And then angles 2 and 3 form another linear pair. So there. So this is using this diagram here so you can kind of picture it. And we want to prove that angles 1 and angles 3 are congruent. So we're proving the vertical angles theorem because the linear pair theorem is really just based on the definition of linear pairs. So, if I am given this statement, or these two statements, that's my reason, and then based on the definition of what a linear pair is, so definition of linear pairs, or definition of a linear pair, either way, I can make these statements. And now, this satisfies the hypothesis for my congruent supplements theorem, and that is the conclusion for my congruent supplements theorem. So my reason for statement 3 is the congruent supplements theorem. Almost done. In this example, we're just going to be determining if the following statements are true or false. So let's draw the picture. If angles 1 and 2 form a linear pair, and angles 1 and angle 4 form a linear pair, and angle 1 and angle 3 are vertical angles, we've now just drawn a diagram and we can use this. All right, we're going to determine if statements are true or false. So we're going to say, are angles 1 and 3 congruent? They're vertical angles? Yes, they are, so this is true. What about angles 1 and 2? Well, they are a linear pair, and if they were both 90, they could be congruent, but we're not told that, so we can't assume that. So in this case, this one is false. What about 1 and 4? Well, again, if they were both 90, maybe. They would, well, if they were both 90, they would be, but we don't know. So that has to also be false. Similarly, 2 and 3 are a linear pair, so that is also going to be another false statement. But angle 2 and angle 4 are vertical angles, so they are congruent, so that is true. Now, an F, the measure of angle 1 and the measure of angle 3. They are vertical angles, so they are congruent, but we don't necessarily know what their measures are, so we can't say for sure if their measures add to be 180 degrees. So this is also a false statement.